Good morning. Today we are going to look at section 2.8, the second part of it. We are graphing two variable inequalities. Our target today is to graph two variable inequalities that are predominantly absolute values. So for graphing two variable absolute value inequalities, our first step is to make sure it is solved for y. Then we're going to graph it using the transformations that we've been talking about. So starting with our parent function of y equals the absolute value of x, we will transform them. And then keep in mind that when we talk about our boundary line being solid and dashed, the same thing applies to absolute value, except instead of it being a line, it's going to be a V-shaped graph. One way for you to remember that is absolute value. Value starts with a V, and your shape is going to be a V. And then we have to remember to shade based on the less than or greater than symbol. If it is less than, we want to be underneath the V, and if it is greater than, we want to be above the V. So typically your graphs will either be shading inside or outside of that V shape. So let's look at our first one. If our parent function again is that absolute value of x, we've transformed this. We have moved to the right 2 and we have moved down 5. So instead of our vertex being right at the origin here, we're going to shift it to the right 2 and down 5. And that's our new vertex. And our a value in this case is a 1. And remember that represents the slope of the right side of our V. So I'm going to, from this vertex, just move a slope of positive 1 on the right side. And I'm going to go backwards and do a slope that's negative 1 on the left. Then I have to look at this inequality symbol. Since there is an equal sign, I know that I'm going to make it a solid V. And since I want y to be less than that amount, I want to be underneath my vertex, underneath the V. So I actually am going to be shading everything under here. Remember, this V keeps going, so we're actually shading all of this, everything that's underneath the V-shaped graph. All right, for our second example, we have y is greater than 2 times the absolute value of x plus 3 plus a 1. The 2 here is going to be a vertical stretch, which means the slope on the right side is going to be stretched and become a 2 instead of a 1. We have moved it to the left 3 because of that x plus 3, and we have moved it up 1. So our vertex is going to shift from the origin again, left 3 and up 1. On the right-hand side, I want to do a slope of 2, so I'm going to rise 2, run 1, rise 2, run 1, and then again I'm going to reverse that to go on the left side. Notice on this one that there is no equal sign, so our V is going to be dotted. And this time we want to be y greater than that, so we are shading above our vertex, which is going to be all of the stuff that's inside that V-shaped. All right, now on this one, there's one thing that makes it a little different from our typical transformation, and that is it's not solved for y. So let's do that first. We want to get y by itself, so we're going to add that 4 to the other side. And now it looks like our usual transformations. Our 2 here is going to be the slope on the right. That's our vertical stretch. So it will be a steeper V. The 1 here is going to move it to the right, and the 4 is going to move it up. So our vertex moves right 1 and up 4. And then we want a slope of 2 on the right-hand side, so rise 2, run 1, rise 2, run 1. Reverse that direction to get the left side, so up and to the left. This one does have an equal sign as part of our inequality, so our line to form that V should be solid. And then we want y to be greater than that amount. So again, greater than the vertex would be everything inside here. All right, for this next one, if we try to solve it for y, we would first subtract the 1 to the other side. But notice that we still have a negative y And to get rid of that negative, we have to divide everything by a -1. But remember, dividing by a negative flips your inequality. So our inequality is really going to turn into y is greater than -1 times the absolute value of x plus 2 plus a 1. So again, I took this -1, divided it from there, it turns that negative, divided it from there, it turns that positive. So analyzing our transformations, the -1 here is going to be the slope of the right-hand side. And since the slope of the right side is negative, it's actually going to be an upside down v, which fits with our transformations because a negative there should reflect it over the x-axis. So we should expect to see an upside down v on this one. Our other transformation is that we have moved it left 2 and up 1. So our vertex, I'm going to start from the origin, go left 2 and up 1. That is my new vertex. On the right-hand side, I want to have a slope of -1, so down 1, right 1. I'm going to go down and left to reverse that on the left-hand side. Since there is no equal sign with my inequality, I'm going to make this a dotted V. And then since I want y to be greater than that, I'm going to be shading everything above it. So remember that when it's a dotted line or V, it means we're getting really close to that, but we're not actually on that line. If it is a solid line, then the points that form that line or V would be included in your solutions. Also remember that you can always test a point to check if you've shaded the right section. So let's say we test this point, 1, 0. Okay, it's in our shaded region, so it should work. We're going to go back to our original equation and plug in 1 for x and 0 for y. We get 1 minus 0, which is 1, is less than the absolute value of 1 plus 2. The absolute value of 1 plus 2 is the absolute value of 3, which is 3. Is 1 less than 3? Yes. Since it worked, we know we've shaded the right section. Now, once we've introduced absolute value graphs, common mistake is that students always want to make everything a V. But remember, if there is no absolute value signs, it's just a linear equation. So this is just a standard form equation for a line. And then because of the less than symbol, we're going to have some shading involved. When we graph equations that are in standard form, our fastest way of graphing is to find our two intercepts. So if we plug a 0 in for y, we would have -2x plus 3 times 0 is, we're going to just use equals here to get our intercepts, and then we will deal with the inequality with the shading and solid versus dashed line. So -2x has to equal 12, which means x would have to be -6. If we put a 0 in for x, this drops out. We've got 3y equaling 12. Y would have to be a 4. So we're going to plot those points. -6, 0, and 0, 4. And then because there's no equal sign with my inequality, I'm going to make this a dotted line. And then when it's in standard form, we really have to test a point, or we have to solve that and get it so that we have y is less than something. Okay? So if it's in standard form, we should test a point. I usually like to test the origin just because it's easy to plug zeros in. So picture putting a 0 in for both x and y, since the origin is the point 0, 0. That means the whole left side turns into 0 and is 0 less than 12. Since that is true, we want to shade the side that has the origin on it, so we are shading this. If you want to check it, let's go ahead and solve this for y. I'm going to add the 2x to the other side, and I'm going to divide out the 3. So I have y is less than 2/3 x plus 4. That fits with my y-intercept being 4. I'm rising 2 and running 3. I guess my line's a little off there. Rising 2, running 3. And because it's a less than, y is less than that, we would be shading underneath the line, which is what we've chosen already. All right, the last little section we're going to do is the reverse. I'm going to give you a picture, and I want you to come up with the inequality. Notice that these are both V-shaped, which means they will be absolute value inequalities. So we're really looking for, some kind of inequality symbol. And then your A, absolute value, x minus h plus k, that basic transformation format. Okay, so first thing I'm going to do is I'm going to figure out my A value. Your A, remember, is the slope on the right-hand side. We are rising 1, running 1, so that tells me that A is 1. Then I look at my vertex. It has moved from the origin here, where it typically is for just our y equals the absolute value of x, the parent function. We've shifted it down 2 and right 3. So we need to make our inequality have that kind of transformation. So I'm going to have y, my A value was 1. You can put it in there if you want. It's not required when it's just a 1. X, since we are going right 3, we'd have x minus 3. And we went down 2, so we're going to have a minus 2 for k. Then we just have to decide about our inequality symbol. Since it is dotted, our red V is dotted, we know that we don't want the equal sign in there. And since we're shading above the vertex, we want to be bigger than it. Okay. For our last example here, looking at our tick marks, notice that they are going by 2s. So this vertex has moved left 4. This would be at a negative 4. So we've gone left 4 and we've gone up 3. Okay? So left 4 would be an x plus 4 inside our absolute value. Up 3 would be a plus 3 on the end. Let's look at our slope. On the right-hand side, let's connect a few dots here that look promising. This would be at a halfway between, which would be a 1. So we are going down 1 over 1, down 1 over 1. So our slope on the right-hand side is a negative 1. And then because we have a dotted V again, there's no equal sign. And because we are above the V, we want to be greater than. All right, we are going to skip this last little calculator part. Just remember that when you are graphing absolute value inequalities, identify your transformation. Your h and your k are going to help you find the vertex. And your A value, remember, is the slope on the right-hand side. And the inequality here is going to tell you if it is solid or dashed. And it's also going to tell you if you are above the V or below the V. So if you have a y is less than, you want to be below the V. And if you have y is greater than, you want to be above the V. Okay. You will be working on a worksheet to practice this material.